Good afternoon, guys. Just wanted to quickly post a video just going over some of the different methods or the primary methods for factoring that we'll be using to solve the quadratics. The first method that we're going to do is going to be, they kind of correspond with the order of the pages in the packet as well. So the first method is going to be, everything is going to be in standard form, ax squared. All right, what's happening? X squared. I don't know why it doesn't want to write in that spot. Let's try that again. There it is. Plus bx plus c. And, excuse me, in this situation, a is our coefficient of the x squared term, b is our coefficient of the linear term, our x term, and c is our constant. So when it comes to the factoring, when I say a, I'm talking about the coefficient of the x squared, b is the coefficient of the x, and c is the constant. And we'll start. So for the first type of factoring, a is going to be equal to 1. Again, this corresponds with page 1, and this is kind of like the most basic type of factoring that we'll have that's of a trinomial, of these quadratic trinomials. So with this one, a is 1. These are going to be the steps that we follow. We list all factors of c. And then step 2, we pick the pair of factors that adds up to b. And then for step 3, we just write our two binomials. All right, so I am going to be working like, straight with the packet, but I just wanted to do it here. I have a little bit more space for work. So basically, I'm just going to give you guys an initial example, then I'll do some from the packet. So if my example is x squared plus, let's say 15x, and then let's say plus 50. So again, we know this is in this particular form because a is 1. So a is that coefficient of the x squared. If that coefficient of the x squared is 1, pretty much this is the type of factoring that we're probably going to be dealing with. Now we list all factors of c. So c for this particular problem is going to be 50. So we need all factors of 50. So factors of 50 is going to be, again, we can start as simple as 1 and 50. Then we have 2 and 25. Next we have 5, 10, and that's pretty much it. Anyone think of anything else? You could add it, but that's pretty much all we got for 50. Now, we pick the pair. Now for step 2, it says to pick the pair of factors that adds up to b. So if we added these factors up, we want it to be our b term. So our b term is 15 here. So this is 51, this is 27, and this is 15. So this is the pair that we're going to pick because we picked the pair that adds up to b. So then we write our two binomials. Our two binomials are going to be x plus 5 and x plus 10. And that is our answer. We have factored this trinomial. Now, the checking of it, you do not have to check it, but just so you know that this would work, if you wanted to, you could go back and check this via multiplication. So the checking via multiplication would be, you would take your answer, and you could easily check to see if you got the right answer. You would just FOIL it back out. Some of you were taught FOIL, some were taught to distribute, some were taught the box method for multiplication. Whatever method you were taught, x, if you do it like this, x plus 5, x plus 10, and you did x times x is x squared, 10x, etc., 5x, and 50. However you chose to do it, or you were taught first, outer, inner, last was the FOIL. But I traditionally just tell my students to always distribute. The little nuances with the boxes and the FOIL don't work as consistently as factoring. It's distributing. So if I distribute x times x is x squared, x times 10 is 10x, and then I go ahead and distribute my other term, and my other term is the 5. 5 times x is 5x, and 5 times 10 is 50. And then I combine like terms in the end. I end up with x squared. These look like Dunkin' Donuts colors. 15x plus 50. So that is my answer. And as you notice, that's what I started with. So I know that I factored it correctly. Again, not a required step to check, but if you wanted to do it, just to make sure you got the right answer, it would be relatively easy to check that. All right, so let's do one or two examples from that first page. So if we look at our first page, here's our packet, here's our first page. We've already done a few in class at this point, so maybe we'll look at number 6. For number 6, for this one, we need all factors of 16 that add up to 8. So if we're looking at 16, that's our C. Our factors are 1 and 16, 2 and 8, and then 4 and 4. That's the only ways to get 16. So if we add them up, we pick the pair that gives us 8. The pair that gives us 8 is the 4 and the 4. So we would write this as b plus 4 and b plus 4. And for our purposes now, we can leave it like that. When we get to a point later, if it's the same thing twice, what you'll see is that I'll tell you guys just to write it as the one time b plus 4 squared if you do get the same thing like that twice. But for right now, you could just leave it like that. All right, so let's move on to our solving of these quadratics. So for the solving, what you're going to do, it's just going to be like pretty much another step or so. Again, at this point, I already talked about this in class. But to solve these quadratics, we're going to use the zero product property. Zero product property says this. It says that if you're multiplying two things and you get 0, then one of the terms has to be 0, essentially. It's saying that then A is 0, B is 0, or both A is 0 and B is 0. So again, the way we connect this to solving the quadratics is in the following method. And not just quadratics, we actually use this for solving. Sorry for yawning. We actually use this for solving pretty much any quadratics. Any polynomials we commonly factor. But so to solve this quadratic, the way you would use this extra piece, this zero product property, is that we would first just start off by factoring. So if we looked at number 17, we need factors of 6 that add up to 5. So C, because again, we're still just going through factoring like normal, so factors of C are going to be either 1 and 5 or 2 and 3. And we have to pick the pair that adds up to B. So in this case, the pair that adds up to B is going to be the 2 and the 3. So we would write it as x plus 2 and x plus 3. Those are our two binomials. But what's different is now from 16 up, those are just factoring. From 17 down, these are solving. And you know that because it says equals 0. It's an equation. You can finish it up. So when it's equal to 0 like this, and we just factored this in this way, essentially this is our A and this is our B. So this, if we're trying to use this zero product property, A times B equals 0, because this is x plus 2 plus x plus 2 plus x plus 3. When we multiply them, we get 0. So both of these are representing like the A and the B from this zero product property. And when we multiply two things and get 0, then one of them has to be 0 or both of them has to be 0. So that's the property we're going to apply here. And we're going to say that x plus 2 equals 0 or x plus 3 equals 0. Again, and this is verbatim from the zero product property. If we multiply two things and get 0, then one of them or both of them has to be 0. And then we solve the two equations. For the first one, we end up with x is -2. For this one, we end up with x equals -3. So our solutions are x equals 2, -2, or -3 for this particular equation. For something like number 20, same approach, but this one requires an extra step because, excuse me, right now it is not equal to 0. Right now it is not in standard form. In order to solve any of these quadratics, we want to make sure they're in standard form. So that's that ax squared plus bx plus c equals 0. So we want to move this -11. We want to do that by adding 11. Why do we add 11? Because -11 plus 11 is 0 now. So we have our 0 over here. And then on the other side, we have our x squared minus 12x plus 11. And now we want to focus on factoring that. So if we're focused on factoring that, we're now looking at c, and c is 11. Didn't mean to write it like that. C is 11. And since c is 11, we need factors of 11 that give us -12. 11 is prime, so it's only 11 and 1. But if we do this, we get +12 when we add them up. So we're going to have to go the negative route because a negative times a negative is a positive. So we'll still get 11, but we'll get the -12 we need for b because we have to watch that sign. 12 and -12 are two different things. So then at this point, we have our two binomials. It's going to be x minus 1, x minus 11 equals 0. And now we solve it. It's going to be x minus 1 equals 0 or x minus 11 equals 0. Plus 1, we get x equals 1. We get x equals 11. These are our two answers, x equals 1 or 11. So that's the extension with the zero product property. All right. Method 2 of factoring is relatively similar to method 1. There's only like one additional step that we're basically going to take on the page 2 or method 2 of factoring. What's going to be different on our page 2 is that these have a GCF. So I'm just going to put like page 2 here. And these terms have a GCF. So what's going to be different is that, let's see. What's going to be different here is that we're first going to look for a GCF. So our first step is to look for a GCF. This is now going to always be our first step for all the other factorings. First thing you want to do is just get into the habit of looking for a GCF. If we have one, we obviously are going to factor it out, etc. And then after that, we just go ahead with everything just like we did before. List all factors of C. Number 3, pick the pair that adds up to B. And then step 4. Sorry about that. Then step 4 is to write your two binomials. All right, so here we go for the second type of factoring. If we have a GCF, the problem's going to look a little different. What's going to look different is you'll see something like this. Here we go. The first example here was 2x squared plus 6x plus 4. So if we have a GCF, first of all, hopefully everyone knows that means greatest common factor. That means something that's common to all of the terms, or something we can divide all of the terms by. When we have a GCF, we're simply going to, we can establish what it is. I'm just going to write it down. The GCF here for this one is 2. Hopefully everyone realizes it's 2. All of these numbers are even. We have a 2x squared, a 6x, and a 4. So we can take 2 out of all of those terms. So that's our GCF. So once we have a GCF, this is what we do with it. We are going to divide each term by that GCF. This is kind of like, think of it as undistributing. Like if you had, sorry, I don't know what's going on with my voice. Excuse me. If you were distributing, you would multiply into the parentheses. When you're factoring or taking out a GCF, you're dividing it out of the parentheses. So it's going to be a 2 on the outside. And then we just go through and do that division. So 2x squared divided by 2 is just x squared. 6x divided by 2 is 3x. And 4 divided by 2 is 2. So the 2 is, again, that has to be on the outside. The GCF must be part of the factoring. It has to be there. Now, after that, you approach it like we do the other ones. All we're focused on now is the trinomial. We're not worried about the GCF. So from the trinomial, we're looking at C, which is 2. And we need all factors of C. In this case, it's 2, so the only factors are 2 and 1. And we pick the pair that adds up to B. So B in this case was 3, so this works. So, because 2 plus 1 is 3, so we're good. So now we write our 2 binomials. It's going to be x plus 2, x plus 1. But we need to remember that one extra thing, though, which was the GCF. You have to bring that down. So it's going to be 2, and then the x plus 2, x plus 1. Let's look at another example where the GCF is not a number, just so you know what to do with that. And this is number 6 on the worksheet. We have a cubed minus 5a squared plus 4a. So for this one, if we look at the terms, one of the signs that the GCF is a letter or a variable, not a number, is the fact that, first of all, it's a cubed. We're working with quadratics, so seeing an a to the third power should be a little alarming because everything else was to the second power. So that's the first sign. Another sign that the GCF is going to be a going to be a letter, is going to be when each term has a letter. If each term has a letter, that means you can take it out, or it could be a GCF. So our GCF for this particular problem is going to be A. And when they all have a letter, or our variable is the GCF, we always take out the lowest power. So in this case, our lowest power is a to the first. Excuse me. And once we take out that lowest power, our a to the first, we have to again divide by it. So each one of these terms gets divided by a. And when you divide, hopefully everyone remembers, but you subtract the exponent. So this is x to the a minus b whenever you're dividing. So right now this is a 1 on the bottom. So a to the third divided by a to the first is going to be a squared. And again, remember that GCF goes on the outside now. Negative 5a squared divided by a is going to be negative 5a, because 2 minus 1 is 1. Let's say 2. And then the last one, with the 4a divided by a, these will cancel out, because 1 minus 1 is 0. It's just going to be the 4. that's left. Again, once you take out the GCF, we focus on the trinomial and factor that. So we need factors of 4 that add up to -5. That's going to be -1 and -4. So it's going to be a on the outside, a minus 1, and a minus 4. That's our answer. All right, so let's look over to the worksheet and do one of those. This is, again, page 2 that had the GCFs. So here's page 2. And on page 2, let's look at maybe, we'll look at number 8. And then we'll look at 1 or 2 for the factoring. So if we look at number 8, for number 8 here, this one has b to the 4th, b to the 3rd, b to the 2nd. So each one of those terms has a b. And again, we can always take out the lowest exponent when it comes to the variables. So our GCF here is going to be, let's make the writing a little smaller here. Our GCF here is going to be b squared, because that's the lowest power we have, or the b's. So we're dividing everything by b squared, b squared, b squared. So at this point we have b squared on the outside, and then we have b squared on the inside, because again we're subtracting, minus 3b, and then minus 10. Again, these b squareds cancel out, and we subtract the exponents for the other ones. So now we have c is -10, and that's what we're looking for factors of. So the factors that give us -3 are going to be -5 and 2. So we have the b squared on the outside, then it's b minus 5 and b plus 2. That would be our answer factor. All right, so let's go to the bottom of the page and look at 1 and 2 of the solving, because again, this is our ultimate goal, the solving. And we'll look at number 15 and we'll look at number 18, and that'll be it for this page. For number 15, when you're looking at that for factoring, again, we want to look for that GCF. So for this particular one, for number 15, our GCF, we got 3, we got 15, we got 18. They don't all have a letter, so we know we can't pull out a letter. Again, we can only pull out a variable letter if they all have a letter. That's not the case here. So no variables are coming out. So we're solely looking at numbers to think about here. So for this one, we have a 3, we have a 15, we have an 18. The GCF is going to be 3. So again, once you've established that's your GCF, it goes on the outside, and that's what we're dividing everything by. So it's going to be x squared plus 5x, and then plus 6 equals 0. Now we're focused on factoring the trinomial that results. So we're trying to factor this. So we need factors of 6 that add up to 5. The only factors of 6 are 1 and 6 and 2 and 3. 1 plus 6 is 7. 2 plus 3 is 5. So that's the pair. So it's the 3 and then x plus 2. X plus 3. Now, again, this is a solving situation, so we keep going. We're not just factoring. So when we're solving, we need to go ahead and set everything equal to 0. We're going to use that zero product property. Oh no, zoom back out. Sorry, zero product property. All right, and with that zero product property, we want to, we want to set everything equal to 0, because a times b is 0, yada yada. Now, what's different about this is the 3. So I just want to show you what to do with the 3, or how to approach dealing with the 3. This 3 is not part of the parentheses, etc. Essentially, you could just think of what to do with the 3 as this. If you wanted to, you can think of it as we divided both sides of the equation by 3, and this would cancel, and then 0 divided by 3 is 3, so it would be gone. So you can think of it that way, but essentially, if it is just a number, so just a number outside, we pretty much ignore it. But the reason we ignore it is because of this process. We could divide it out and get rid of it. So we're not going to need to deal with the 3 at this point. So now that it's time to solve, we're going to go ahead and just do the x plus 2 equals 0, or the x plus 3 equals 0 to get our solutions. So minus 2, we get x equals negative 2. And minus 3, we get x equals negative 3. So those are my two solutions. Now 18 is our last problem here, and then I'll start another video for the other one, so it won't be too long here. So for 18, for this one, what we're going to do is again look for a GCF. GCF here is going to be x. Each term has an x, so we know we can take out an x as our GCF. Again, another immediate alert or flag would be because it says x to the third. If it says x to the third, we know that it's not a quadratic, so we probably can take out a variable there. So first thing I would do is take out my x. Everything gets divided by x. I have x on the outside, and I'm left with x squared plus 11x minus 12. Again, those cancel, and we subtract the exponents for the others. And again, this is an equation, so I need to keep my equal 0 here. Now I'm trying to factor this trinomial. So I need factors of negative 12. That give me 11. So factors of negative 12 that add up to 11, it's either going to be negative 1 and 12 or negative 12 and 1. The one that adds up to 11 is going to be the top one here. So it's going to be x, because that was already there on the outside, x minus 1, and x plus 12. And now we solve what results. So what results here is we have to do x. Now, what? Okay, I'm sorry. Actually, let me address this. So what is different from 18 and 15 is the following. That's why I wanted to do this one. This is a variable outside. So that's not going to be the same as the previous example where I said you can just divide out by the 3 and get rid of it essentially. In this case, because it's a variable, we're just extending the zero product property. It's going to be x equals 0, because this is now 0 too, x minus 1 equals 0, or x plus 12 equals 0. So it's like a times b times c equals 0, then a, b, or c equals 0. So we're essentially just extending it if it's a variable there. So this is our first answer. Our second answer is 1. And our third answer here is 12. Now, a lot of you are probably thinking, in the beginning when we started with the quadratics last week, that I indicated that there would only be 1, 2, or no solutions. That's going to be the case if it's a quadratic. This one is obviously not a quadratic because it's an x to the third power. So that's why this one has 3 answers. I'm just going to show you quickly on the computer. I'm sorry, on Desmos. Give me 1 second. All right. So if you look here, I typed the equation into Desmos. This is the online graphing calculator. Again, it's linked at the top of your Canvas page. This is the x squared plus 11x minus 12x. So again, this is not a quadratic, it's a cubic because it's to the third power. And when we talked about the different types of graphs, we should expect some type of S-shaped graph, you know, some type of different situation whenever it's a cubic. And if you look at this, these are the solutions. Here's the first solution we just got at 1. Sorry, I'm moving the graph. Here was the first solution at 1. Here's the second solution at 0. And here's the third solution at negative 12. So if we go back, again, those are the three answers we got. We got 0, we got 1, we got, ooh, sorry, that's negative 12. It's my fault there. And that's a negative 12. So those are the same answers we got here using the graphing calculator app. All right, so we'll stop here for this video. The other video, we'll do the last two types of factoring. Have a great day, guys.